The next that we are going to be looking at is the electrical test on the vacuum circuit breaker. So it's not different from what we have been doing. So the basic test is as we had outlined earlier before on others, the contact resistance test, the bolted connection resistance test with a low resistance meter, the milliohm meters, and then the insulation resistance test. Then we can also do the tan delta since we are looking at high voltage. Okay, we can also do the tan delta test to check the insulation. And also we can, so we want to perform the resistance test on bolted connection, the ones that we can access. But if not, then we can actually let go. Okay, we are to use low resistance ohm meter. So on the resistance on the contact resistance, as we'll see later, we need to close the breaker. Okay, so once it is closed, we test across the face. So that the resistance, we need it to be close to zero as much as possible. Zero the better. So that will give us the contact resistance. So as resistance is building, we have the vacuum bottle here or here. As the resistance is building between the contacts, that will kind of increase the resistance. So we also want to check the insulation resistance of the circuit breakers. That is, we want to look at the insulation between faces, okay, and between face and ground. So that is what we want to do. So we want to follow our laid down procedure in our facility. The what is expected or recommended by our facility is what we look out for, or what is recommended by that equipment manufacturer. So in the absence of that, we can use this table as usual. Okay, so we have the operating voltage on the far left, the middle, the amount of test voltage that we can inject. Then we also have the minimum resistance level. Okay, so if you are not too familiar with how to carry out insulation resistance tests, you can check the description below for a link to the video training on how to perform insulation resistance. Okay, so like we said before, you do the resistance on there is the okay, you perform insulation resistance on the control wiring. Okay, but in this case again, you need to be very careful. Follow the recommended procedure by your manufacturer so that will not destroy sensitive electronic components in the control circuitry. So this is the low, this is a very versatile meter that we can use also. So this is the low resistance section of the meter. You just to turn this selector switch to, and then you probe both ends when it is closed, especially when you are looking at contact resistance. So this is the capsule housing the vacuum. Okay, so this is the movable part of the contact, and this is the stationary part. So when it is closed, when you probe these two ends, what you are doing is actually testing the resistance between these contacts. So that is the contact pole resistance test. So the next test that you will do using the circuit breaker analyzer is to perform the minimum pickup voltage test on the trip coil and the closing coil of the circuit breaker. Then you also want to perform power factor tests or dissipation factor tests. If you are not still familiar with power factor testing procedures, you can also look at the description below for a link to the power factor video training on power factor testing. So what you will be doing during the power factor test is actually to test the insulation between phases, okay, of the circuit breaker and between face and ground. So with the breaker in the test position, we can carry out the following tests. We will trip and close the breaker. Okay, that's we can switch on after racking the breaker, we can switch on off the breaker, that's the trip. Then we can switch on the breaker. Okay, so we should trip and close the breaker with those control buttons or switches. So we'll trip the breaker too by operating each of its protective relays. Okay, so we can do that by sending the appropriate signal to the protective relays. That is secondary injection now, to see how the circuit breaker will respond. They also want to see that the mechanism is charging properly. Okay, as we are charging it, if it is motorized, we want to see that the motorized function is also, the motor is also operating properly. So we want to see that it is trip free, and we also want to see that the anti-pump function is working properly. Then we can perform the electric withstand test too, to see verify that the dielectric strength, that is insulation, can withstand the operating voltage. But in this case, as you can see in this table, we need to subject it to a higher voltage, more than the nominal voltage, the operating voltage. So we'll do that either with AC signal or DC signal. Remember, we are not, it's already in operation or is in our facility already. We are not carrying out factory tests. What we are doing is the equipment, the circuit breaker is in the field already. So this is what we'll be looking at. Okay. So next, we want to look at the vacuum bottle to see that the vacuum bottle has not lost its integrity, it has not lost the vacuum. So the vacuum, like we said earlier, is here. That is where the bottle that is housing the contact. Okay, so the vacuum is what is providing the insulation. So if the vacuum is not there, when the circuit breaker is opened, the circuit breaker could be conducting. So we want to check the integrity of the vacuum bottle. Okay, and we want to follow the recommended procedure by the manufacturer in doing this. So this is where we have the vacuum that actually insulates the contact, okay, the space between the contact. So if there is no vacuum, you see that electricity could be conducted through even when the contact is open. Remember, we are dealing with high voltage, high pressure that can drive current through. So we want to be sure that the vacuum bottle integrity is intact. So we want to, all those electrical connections, we want to verify that they are the ones that are accessible. We want to see that they have the appropriate torque on them. They are tight and firm. We want to use calibrated torque wrench, and be sure that we apply the appropriate torques. Okay, so those are some of the things that we need to check out for to ascertain the integrity of our vacuum circuit breaker, so that we can release it back into operations.